Hi everyone, welcome back to PRAKASAM tutorial. In this video, I am going to discuss about example of wide sense stationary random process. This is the previous examination question. The example is prove that the random process x of t is equal a cos of omega ct plus theta is wide sense stationary if it is assumed that capital A and omega c are constants and theta is a uniformly distributed variable on the interval 0, 2 pi. Coming to the solution, given that the random process x of t is a cos of omega ct plus theta. So now here in this random process, capital A and omega c are the constant and theta is the uniformly distributed random variable over the interval 0 to 2 pi. So we know that the uniform probability density function of the random variable x expression is 1 by b minus a for x is equal to a to b. So this is the standard expression. So now here theta is a uniformly distributed random variable and its probability density function is f of theta is equal 1 by 2 pi minus 0 for theta is equal to 0 to 2 pi. So the condition for WSS process is wide sense stationary process is the mean of the random process is constant and the autocorrelation function is depends only on tau and not time t. So first calculate the mean of the random process. So we know that the mean value of the random process x of t is expectation of x of t is equal integral minus infinity to infinity x of t into fx of x dx. So now here the random process x of t is a cos of omega ct plus theta and theta is a uniformly distributed random variable and its probability density function is f of theta. So here expectation of x of t is equal integral minus infinity to infinity x of t and the probability density function is f of theta into d theta. So now applying the given data. So given that the random process x of t is a cos of omega ct plus theta and probability density function of the random variable theta is 1 by 2 pi into d theta over theta is equal to 0 to 2 pi. So 1 by 2 pi is constant, a is constant that is written before integration. Expectation of x of t is equal a by 2 pi integral 0 to 2 pi cos of omega ct plus theta d theta. So integral cos of omega ct plus theta is sine of omega ct plus theta over 0 to 2 pi. So now substitute upper value of theta and lower value of theta. We get a by 2 pi into sine of omega ct plus 2 pi minus sine of omega ct plus 0. Sine of omega ct plus 2 pi. Sine of 2 pi plus omega ct is sine of omega ct that is equal expectation of x of t is equal a by 2 pi sine of 2 pi plus omega ct is sine of omega ct minus sine of omega ct. So now here plus sine omega ct minus sine omega ct is the cancel. This within the bracket term is 0. A by 2 pi into 0, 0. Expectation of x of t is equal to 0. So 0 means it has some constant value. Expectation of x of t is equal to constant. So therefore the mean of the random process is constant. The first condition is satisfied. The first condition is satisfied. Hence, the given random process x of t is a stationary random process. And second condition, verify the second condition. The autocorrelation, we know that the autocorrelation function of the random process x of t is given by Rx of tau is equal to expectation of x of t plus tau. So given that the random process x of t is a cos of omega ct plus theta, substitute that x of t value into here. Expectation of a cos of omega ct plus theta. X of t plus tau is a cos of omega ct plus omega c tau plus theta. X of t is a cos of omega ct plus theta. In the given random process, substitute t is equal to t plus tau. We get x of t plus tau. So the x of t plus tau value is a cos of omega ct plus omega c tau plus theta. A into a square. A square is constant that is written before expectation that is equal a square by 2 into so a square and after that multiplying numerator and denominator by 2, we have a square by 2 into expectation of 2 cos of omega ct plus theta cos of omega ct plus omega ct plus theta. So this within the bracket term is 2 cos a cos b. 2 cos a cos b expansion is cos of a plus b plus cos of a minus b, that is equal r x x of tau is equal a square by 2 r x x of tau is equal to a square by 2 expectation of cos of a plus b cos of omega ct plus theta plus omega ct plus omega c tau plus theta, that is cos of a plus b plus cos of a minus b cos of omega ct plus theta minus of b. So multiplying minus within the bracket term, we have minus omega ct minus omega c tau minus theta. So omega ct 2 omega ct theta plus theta 2 theta. Therefore rxx of tau is equal a square by 2 expectation of cos of 2 omega ct plus omega c tau plus 2 theta plus cos of minus omega c tau. So cos of minus theta is cos theta. Now here second term is cos of minus omega c tau is cos of omega c tau. Now using expectation of the random process expression, expectation of x of t is integral minus infinity to infinity x of t into density function into dx. So now we are first applying the expectation here within the bracket term. Rxx of tau is equal a square by 2 into expectation of cos of 2 omega ct plus omega c tau plus 2 theta plus cos of expectation of cos of omega c tau. So expectation of x of t. Now here the function is, in the first term function is cos of 2 omega ct plus omega c tau plus 2 theta, and the second term the function is omega c tau. So using expectation of x of t basic expression, this expectation of this function is integral 0 to 2 pi. Now here the function is cos of 2 omega ct plus omega c tau plus 2 theta into, now here the theta is the random variable and its probability density function is 1 by 2 pi into d theta plus a square by 2 into, and the second term, now here the function is integral 0 to 2 pi, function is here cos of omega c tau into density function of the random variable theta, and its value is 1 by 2 pi d theta. So 1 by 2 pi is constant, that is written before integration, that is equal rxx of tau is equal a square by 2 into 1 by 2 pi into integral cos of 2 omega ct plus omega c tau plus 2 theta integration is 1 by 2 sin of 2 omega ct plus omega c tau plus 2 theta over 0 2 pi plus a square by 2 into 1 by 2 pi into, now we are the integrating with respect to theta, and the second term is integrating with respect to theta cos omega c tau is constant, that is written before integration. So that is second term is a square by 4 pi cos of omega c tau into integral 1 d theta. So now here in the first term substitute upper value of theta and lower value of theta, and substitute upper value of theta a square by 8 pi into substitute upper value of, okay, and first integrating here this second term integral 1 d theta is theta over 0 to 2 pi. So now we have the substitute upper value of theta and lower value of theta, we get rxx of tau is equal a square by 8 pi into sin of 2 omega ct plus omega c tau plus 4 pi minus substitute lower value of theta minus sin of 2 omega ct plus omega c tau plus 0 plus, and the second term a square by 4 pi cos of omega c tau, and substitute upper value of theta and lower value of theta, we have 2 pi minus theta. So now here sin of 4 pi plus 2 omega ct plus omega c tau is sin of 2 omega ct plus omega c tau minus second term is sin of 2 omega ct plus omega c tau, and this is the plus term, this is the minus term, these two terms are the cancel, this within the bracket term is 0. So 0 into a square by 8 pi is 0, and the remaining term is rxx of tau is equal rxx of tau is equal a square by 4 pi into cos of omega c tau into 2 pi. So now we are in the second term, numerator and denominator 2 pi is the cancel, we get the remaining RHS term is rxx of tau is equal a square by 2 into cos of omega c tau. So now in this equation the autocorrelation function is depends only tau. only depends on tau. Hence, the second condition is satisfied. Therefore, the given random process x of t is a stationary random process. So this is the procedure we can determine the given random process x of t is stationary random process or not.